Boom. Every time.
Every time. It's awesome.
Every time. The soundtrack that will forever live in my head. So, hey, everybody. Welcome to Containers from the Couch. If this is your first time ever joining us, which I doubt it is. We've been doing this for 3 weeks. It's like we've been doing it for 3 years at this point. But what we like to do is talk anything containers, container services on AWS. Brent and myself, we are on the container services team as developer advocates. So we like to just kind of dive in and play with container things. So Brent, what are we doing today?
Well, today, so this is actually, it came from a question from one of our earlier sessions. So with that, I want to encourage you to throw questions in the chat. Find us, you're hopefully watching us on Twitch, twitch.tv/AWS, and give us a follow and get alerted anytime we go live, so that you know when to watch this show. We are going to be here the same time, Monday through Thursday, almost every week. This Thursday, we actually have a special event on our Twitch channel happening. Adam, do you know anything about that? It's a very special event.
Yes, it's our Containers Conference. I think this is the inaugural, it's a tough word to say, inaugural Containers Conference. It's going to be on Twitch, and I have a session where I'm going to be doing a talk on capacity providers, doing a deep dive, but a lot of cool stuff. We talked about Copilot. There's going to be a talk about Copilot. Just some really, really cool stuff. So definitely tune into that.
Yeah, definitely tune in. You'll be the first to know about some new stuff that we're going to be releasing. This is where we're going to be letting you in on all kinds of new stuff, and then we're going to be featuring some of our latest features and releases and functionality and stuff like that. We're going to have engineers on. We're going to have general managers on. We're going to have all kinds of people on that are going to give you all kinds of cool information about the latest goings on with our container services. So you don't want to miss that. It's going to be coming up on Thursday. So tune in, twitch.tv/AWS, and it's basically going to be all day. So watch for that.
And I will post a link to register for that in the chat.
Perfect. When you do that, I'll also flash it up on the screen, unless you have the capability of popping it up on the screen.
I don't. I'm not that special.
All right. Well, we'll work on that. So
I just posted it.
Copy. And see how I have to talk my whole way through it. Let's make this a banner.
See, as you can see, we're pro streamers here. This is we learn every second of the day here. Constantly learning.
Totally. All right. That's the URL. To sound it out, it's AWS Cloud Container. Whoa, let me start over. AWS Cloud Containers Conference.splashthat.com. sign up now. It's an open registration. It's free, so you definitely want to sign up so that you can attend. And that will, there's a button. I even signed up, by the way. There's a button that you can click that will add it to your calendar. That way you don't miss it or forget about it, because it's going to start earlier than this show normally starts. So you definitely want to watch that and just keep it going all day. Watch it, keep it in the background while you're working. There's an agenda posted. If there's something that is especially interesting to you, tune in. If there's something that you want to throw in the chat here today and talk about, you're welcome to do that. So all that was to, just mention that what we're going to talk about today came from an earlier chat question. Someone was asking about, what are the different ways to expose my service? Now, they didn't ask it that way, but that's really what they were getting at. How do I get traffic that, into a service that's running on my Kubernetes cluster? So I thought, this is a good time to take a look at that. And we'll look at the sort of various different ways that you have to be able to share traffic inside the cluster and then outside the cluster as well. So uh, with that, let's just get to it.
Yeah.
All right. So if you want to follow along, we are working from eksworkshop.com, and the chapter that we're going to be looking at today is called Exposing a Service. So you're perfectly welcome to follow along there, or watch us now and then go back and do this later on your own if you want. That's totally cool too. All right. Let's see here. Where do we get started? What are some of the what are some of the problems that we're trying to solve when we're talking about exposing a service? You know, at the most basic level, what we try to do is we try and run a container on our cluster. And let's pretend for a second that that container is an API or something that needs to take traffic. Um, we can't just stop at running the container, right? Or running multiples of the container. We have to figure out how do we get traffic into that container. It's a problem that comes up in all the different orchestration platforms, and it gets solved in a slightly different way in each one of them. So we'll take a look at how do we do it for Kubernetes. And most of this is not EKS specific. At the end, we'll be looking at one thing that is sort of EKS specific, and I'll point that out to you then. Okay, so when we run an application on Kubernetes, uh, when it normally comes up, it's normally assigned, an IP address. If you think about just the way networking works on Kubernetes, uh, the normal, well, without even Kubernetes, just talking Docker, the normal way for networking to work on Docker is Docker containers on a host come up, and they're typically, I think the default is to be, connected to a bridge. So they're in their own little sort of private IP space, and then there's a bridge that they can connect to get out, outside of their own little space. So while they're in their space, they can talk to each other because they're in this shared IP space, and those IPs are on the same subnet and therefore able to talk to each other. But when they need to go out, that's when things really start to get complicated. So imagine you're talking now about a container on host A and a different container on host B. They can't talk to each other even though they might be in the same IP space. So we have to come up with a different mechanism for connecting those two applications together and allowing them to talk to each other. So to demonstrate that point, I want to just create a really, really simple deployment. And let's look real quick at what this is doing. We're creating a deployment. We're naming it my Nginx, and I bet you can guess we're going to be running the image, the official Nginx image. We're just using that as super basic, nothing special. And then we're specifying that that container port 80 is the port that traffic should be hitting, that traffic should be going to. Really, really basic, right? So once we do this, we're going to put this in a namespace just to keep things a little tidy. So we're creating a namespace, my Nginx, and then we're going to apply that manifest that we just wrote. So we just applied the deployment. And if we want to check get pods, you see that we're already running. We've been up 8 seconds, and we already have IP addresses assigned. Now, can I reach those IP addresses? The answer is no. If I were in the cluster, then I would stand a pretty good chance of being able to. But the problem is if I kill a pod and its replacement comes back, it's going to get a different IP address. So I would have to contend with IP addresses constantly changing and stuff like that, even if I'm in the cluster. And if I'm outside the cluster, there's just no way to reach this as it stands right now. So how then should I access this or send this traffic? Well, there's another object in Kubernetes, and it's called a service. So what we need to do is, along with the pods that we defined, the deployment that we defined, we need to define a service. So real quick, let's just show that get pods, I'm grepping for pod IP. You'll see that we have each pod has its own unique IP address. This is something that I think is pretty cool. I remember I was working with Mesos back when Kubernetes really, hit the scene. I forget what version Kubernetes was, but it was pretty early in the day. And one of the most unique things about it at the time was that each pod came up and it was assigned its own IP address. And that was really cool because back then I was fighting with assigning ports on hosts. So as my Mesos cluster would grow and grow and grow, I could, allocate a specific port to a specific service, but then that really meant I could only run one per host of that service. So that was obviously not going to scale very well. With Kubernetes coming up and assigning an IP per pod, that meant that all the port space was available per IP. So each pod has had the full range of ports available to it. So port 80 in this IP and port 80 in the second IP are both perfectly available. I only have 3 hosts in this cluster, but I could scale this up to 10, and I would still have port 80 available on each of the pod IPs. So that's really cool. This whole concept of unique IPs per pod was something that I first saw early in Kubernetes. Okay, so you'd think then what we might be able to do is route traffic to any of those IPs and talk to port 80, but the problem is we don't actually have anything that's in that IP space. So that's an IP space that I can't really reach from outside the cluster. Also, again, like I mentioned, pods come and go. You don't want to build anything around the IP space or the IPs that pods actually have. So what we want to do is attach something called a service. So we can there's a really simple command to build a service. We're going to look at a couple of different things we can do, but the easiest or the simplest, most straightforward thing to do is to just expose the service. So in my namespace, my Nginx, I can expose the deployment, my Nginx. And once I've done that, I can actually get service. So again, I'm doing this all within my namespace, the namespace my Nginx, and I'm just running get service my Nginx, and you can see now there's something called a cluster IP. Now this cluster IP, here's what you need to know about it. One, it's virtual, so it doesn't exist outside the cluster, but two, it doesn't change. And that's really the key bit that makes this easy to use and easy to consume. So once I have this unchanging IP address, I can start to build around it, and I can start to expect that it's always going to be there, and I can send traffic to it, and then I know that when I send traffic to that IP address, it'll get routed to whatever dynamic IPs that the pods currently have. All right, let me grab a drink real quick.
And I'm just working on putting something in the chat so people can follow along, eksworkshop.com. So I'll be putting a message in there. So
Awesome.
As you're going through this, people can follow along.
Absolutely. And yeah, throw questions in the chat. Adam will be there to either answer them or relay them. So definitely fill up the chat with all your questions. So once we have the service exposed, we have this cluster IP. The cluster IP is the default way of building a service. So when we specify that we want a service tied to my Nginx, we're going to get cluster IP unless we specify otherwise. And we'll be looking at the other choices in a minute. But for now, let's just talk about cluster IP. If we describe the service, we can get a bit more details here, but we can see that what we're doing is we're using a selector to find all the matching pods, and the selector is my Nginx, so that's pretty straightforward. The IP is the thing that, again, it won't change. So I can, if I can resolve to this or I can reach this, then I can send traffic. And you'll see that the endpoints are listed here. These are dynamic, and those will change. So as pods come and go, as they go healthy and unhealthy, they'll get added to or removed from this list. So that's how we know where to send traffic when it comes in on the cluster IP. All right, so let's actually try it out. What we're going to do with this command is we're going to just set a variable that is my cluster IP. So just to test that, my cluster IP, you see it's that virtual IP, that cluster IP. And then what we're going to do is we're going to launch another pod, another container. This is just the BusyBox container. We're just going to drop into the shell of a BusyBox container. This is just to give us some tools that we can use to test things out. And if we then do a wget to my cluster IP, then you'll see we get back the Nginx welcome page. So if we want to not have a variable, but actually just use this just to sort of prove it, you get the same thing. And of course, if we want to take out the grep, you can see we get the full HTML page. So very, very simple, very, very basic. We have two Nginx containers running, and we are curling, or wgetting in this case, to port 80 of this virtual IP, this cluster IP, and we are getting directed to or routed to the port 80 of one of those containers, and we're getting back a response. Very simple stuff. So this is the most basic way to expose this kind of service. Okay, so when would I use this? That's usually the next question. The answer is when you have internal cluster traffic that needs to talk to this service. So in other words, east-west traffic is probably a good way to describe this. When I have a service over here that needs to talk to this service, it can do it using the cluster IP. And what's nice is the cluster IP is not exposed outside the cluster. So I can't get traffic from outside in. That's usually referred to as north-south traffic. But once you're in the cluster, traffic that's just going from A to B, all staying inside the cluster, east-west traffic. So one API talking to another API, that kind of thing is definitely a good candidate for using cluster IP and exposing a service as a cluster IP service.
Hey, Brent, would you recommend any other ways for that east-west traffic as compared to cluster IP?
Yeah, so there's all kinds of other choices here. This one is the most basic. This is sort of your starting point, but you can then start to, if you want to continue to explore the path for east-west traffic, one popular way to do east-west traffic or to handle it or manage it is to build a service mesh. So service mesh is definitely coming along. It's really its own topic. It's can be complicated. It's very feature packed. Let's just say that. So a lot of times with east-west traffic, you might also be trying to solve the problem of I need to encrypt all that traffic, and I need to authorize it and authenticate it, and I need to rate limit it, and I might need to build in retries. So like all that stuff can be solved using a service mesh. So in a future show, we'll talk service meshes, but for now, we're going to keep it super simple, and we just want you to understand the concept of east-west traffic using cluster IP, really basic service definition and service exposure.
Cool.
Yeah. All right, so let's drop out of this test container, and we'll continue on to the next uh, example. So if we want to access, like I've been saying, if we want to access the service within the cluster, just using the cluster IP is super simple. But what about that east-west traffic? How do you tell service A where to find service B? That's another problem that we have to figure out and we have to solve. And there's a couple of answers here, and one of them I actually didn't realize until pretty recently. So let's take a look at what we have running real quick, just to sort of refresh our memory. We have in our MyNginx namespace, getpods-o wide, we have that load generator pod that we were running to just sort of test things out and use as a jumping in point. But then we have our MyNginx services. So let's just go on, and what we're going to do is we're going to look up a pod ID of one of the MyNginx services. In fact, I'm just going to do this line by line so you can see it. So my pod, you see how it just returns the load generator pod. So this is just how can we get back into the load generator pod. And what we're going to do is we're going to exec into that load generator pod, and we're going to explore the environment, all the environment variables that are part of that pod. So this is what I find to be most interesting. There's an environment variable called MyNginx service host and MyNginx service port. Let me do this again, and this time I'll sort. So that makes it a little bit easier to spot MyNginx service host and MyNginx service port, and notice what what the values are, port 80 and my cluster IP. So I could actually build my service, and when it comes time to have it like know where to find my Nginx service, it could just read the values from the environment. I think that's really interesting. The other thing that we have available to us is DNS-based service discovery. So this you could think of as being environment-based service discovery, but we have DNS-based service discovery available to us as well. So if your application is good at resolving DNS, feel free to do this too. So for DNS service discovery to work, what we have to have is a DNS server that is basically plumbed into the Kubernetes API, so that as pods come and go, as they go healthy and they go unhealthy, we can have A records, appear and then get removed so that we can route traffic. And those A records would resolve to the service IP. So that service IP is just going to route the traffic to whatever pod IPs are currently healthy. So let's test this out. So we're going to, we check to see we're already running Core DNS. Core DNS is technically an add-on, I think. Still, it used to be, but it's included with EKS. So if you're, working on a cluster that you built yourself, and not knowing what instructions you may have followed, you may or may not have Core DNS. But if you're using EKS, then it's there. We install Core DNS by default. Core DNS used to, it replaced a service called kubedns. So you can actually still find references to kubedns, when you query for app named kubedns, you get back Core DNS. That's for backwards compatibility. So that's why this command is written this way, is because Core DNS replaced kubedns not too long ago, a couple of versions ago. Okay, so here's what we're going to do next. We're going to launch a BusyBox container. And again, we're going to use this as kind of a jumping in point into our cluster, and we're just going to look around, use this to run commands to look around and see what's out there and available. Again, we could print in and grep my Nginx. And you see, again, we have my Nginx service host and my Nginx service port. We could totally use that information for service discovery, but we could also use DNS. And so the way we would use DNS would be, simple NS lookup for my Nginx, and it's going to return back that cluster IP, 10.100, 121, 118. And notice the fully qualified name, mynginx.service.cluster.local. So the way this is layered, .local obviously is the TLD, .cluster is everything on this cluster. .service means this is a service that is exposed. My Nginx is the namespace, and then my Nginx is the service name. So the service name, namespace, service.cluster.local is typically how you would resolve things using DNS.
And Brent, a good question came in that I want to throw your way. So it came from Two-Door, and it's so the Kubernetes DNS is only used in the cluster, like a general etc host file, and as a service? ?
It is a service. It's not like an etc host file, but it is only used in the cluster, if that makes sense. I don't know if what was that, Adam, do you remember the name of that service that you used to run, or that could be run, where it would read your etc host file and then it would resolve DNS for you, and make your etc host entry available over DNS?
Is that DNS mask?
That's right. Yeah, DNS mask. So you could almost think of Core DNS in the same way as DNS mask, but instead of the backend database being etc hosts, it's really the Kubernetes API. So it's whatever Kubernetes has stored in its state at the time. And then anything that gets, that you're trying to resolve beyond the cluster just gets routed to whatever upstream DNS servers you happen to have configured. So you can see here that the server 10.100.0.10, that's one of the core DNS servers. And then if I try an NS lookup, you see we still hit the same core DNS server, but we went upstream to find these IP addresses. So that core DNS server didn't have it in its local backing store, so it went upstream and resolved it for us. Okay. Any other questions? Or and did
No,
that one, do you think that actually answered the question?
I think so. And also, if there was an, I think it did answer the question. But also, if there's a need to plug into external DNS like Route 53 or some other DNS provider, um, there's a controller out there. I'm going to find it.
Yeah. So
And
that does come up too. That's pretty advanced level. Um, so what you can do, there's all kinds of cool things you can do, by the way. One of the things that you can do is you can set up your cluster to resolve using Route 53. And then thing number two that goes along with that is you can have your services announced into a Route 53 zone. So at that point, instead of core DNS, you would actually be using Route 53. Why would you want to do that? It's entirely possible that you can overwhelm core DNS, and it's less likely that you'll overwhelm Route 53, given that it's one of the only services that offers 100% uptime guarantee from AWS. So, I mean, I'm not saying it can't happen, but yeah, it would be cool to see it happen, I suppose, or interesting.
yeah,
It's shocking, might be the best word to put it.
yeah,
I'm not encouraging anyone to do anything, but
careful.
yeah, yeah. Let me roll that back. But no, I think it would be a bit of a shock to see that happen.
Yeah.
All right. So what have we done so far? We've run a couple of Nginx pods, and we just saw the IP spacing and the IP addresses that they got. We then built a service that we could use um, to reach those IP addresses and route traffic into those pods. We then explored how to discover the service IP address, and you can do that either using environment variables in pods; those are just injected automatically, or DNS to look up the service name. Um, yeah,
Good question
yeah,
just came in. Good
yeah.
question just came in. Okay. So, by the way, yes, you did answer the other question. So that was good. When I run Docker containers locally, they don't use my default profile for IAM credentials. Do I have to inject access keys into my container to interact with services such as Dynamodb? So this is kind of a unrelated topic,
Woo!
but
Okay. We actually are going to touch on that a little bit. Let's hold that question because I think in the next section we're actually going to do that, or maybe it's the section after this. But we're going to answer that today. So yeah, let's hold that thought. We'll come back to it. I
perfect.
love that you asked that though. That's a good question. Thank you for teeing that up. Okay, so we have our service. It's built. We can reach our Nginx pods, but we can only do it inside the cluster. So what about the scenario when we want to get traffic into the cluster from outside? How can we do that? So let's take a look at how we can expose the service beyond the cluster. So let's recap real quick. Let me get out of this. And then we're just going to get service. We see the cluster IP. We're all good. Let me leave that on the screen real quick. And you can see cluster IP. Also of note, external IP is currently none. That's where we're going to go next. And port 80 is the relevant port for the traffic. Okay. I mentioned earlier the default service type is cluster IP. So when we exposed that service, we built a cluster IP service. Well, what if we don't want a cluster IP service? What if we want instead a type load balancer service? So what we can do is patch the existing service object. So here we are, -in namespace, my Nginx. We're patching the service, my Nginx, and then -p is the patch that we're passing in, and we're passing in JSONs. The spec type is now going to be load balancer. So my Nginx has been patched. This is a way of editing the existing object. So if we go back and we get service again, that existing object now has a new external IP available. So you can see that we are routing traffic now from this external IP address into the cluster IP or into the pods. So how can we test this out? Well, it's going to take a few more minutes, but we'll go ahead and walk through the test, and then we'll see that it won't work right away. But if we set a variable for load balancer, you see that all we're doing is we're setting a variable to that load balancer name. We queried kubecontrol-n my nginx get service my nginx -o JSON path. This, by the way, is an advanced kubecontrol command that you can use to look up all kinds of information. So if you're ever wondering, like, how can I get at some piece of information that you can see in kubecontrol output, check out querying and outputting with JSON path. That will that's a very sophisticated, very cool way of getting at the precise information you want. So check that out. Okay, so our load balancer. Let's see if it's alive yet. What we're going to do is just curl our load balancer. Cool, it's alive. So we waited long enough, and our load balancer is indeed alive. And just as a secondary test, if we wanted to copy and paste this into our browser, do I have a browser in this screen? I don't. 1 second. Here's browser. Here's our address. And there's our welcome to Nginx page. So you can see pretty easily that we're exposing this all the way out to the internet. If you wanted an internal load balancer, you could also do that too. It's a similar object, it just has a different label, but you can definitely expose to internal VPC traffic only, or you could expose external public traffic. This is the normal thing to do.
And it appears that we have lost Brent. So that is awesome. Let's wait to see when he comes back. Nothing better than being put on the spot. In the meantime, while we wait for Brent to come back, oh, he's back.
Yeah, sorry about that. That's what happens when you close the wrong window.
It was so awkward. I'm just like, what's going on? Now it's just me. I've been silent so long. Okay.
I know, right? Dance, Adam, dance. All right, let me get my screen shared again. Sorry about that.
Cool.
All right, here we go. So pick back up where we left off. I will try and remember to not close that tab. And all right, we have our. So what we've built is a load balanced service that is exposed using ELB. And let's actually explore that real quick. Once again, I'm going to the browser. I really, remind me before I close anything to not close the wrong thing. So what we're going to do here is we're going to log into the EC2 console, and we're going to look at our load balancer.
I just posted a couple of links in the chat. One was around just an ECS question I answered, but a lot of talk still around IAM roles for Kubernetes pods. So like if you don't get to it, Brent, it's already going to be answered and done.
Fair enough, fair enough. That's coming up next.
There's so
All
much
right.
excitement around this.
God, we'll have to have a show on this.
Yeah.
So, all right. Let's see. I'm in the Ohio, my cluster's in the Ohio region. So here we go, here we go.
Here we go. Here we go.
Wow. Okay, here it comes. So that load balancer address, that DNS address, we can see is an ELB or a classic load balancer. Um, the naming for this has fluctuated, in recent history. It used to be ELB, then we started calling it Classic Load Balancer, and now I think people have shortened that to CLB. So yeah, call it whatever you're most familiar with, whatever you prefer. But here's the upside and downside to using this type of load balancer. The upside is it's super easy. So this is going to attach, it's going to send traffic into your instances. So we can see that all three of my worker nodes are in service. Then they are all going to be able to receive traffic, and whichever one is, accepts the traffic is then going to route it to the appropriate service location inside the cluster. The downside is when I want to bring up a second service, I'm going to have a second classic load balancer provisioned. When I bring up my 20th service, I'm going to have my 20th classic load balancer provisioned, and so on and so forth. So it can start to get to be expensive, a little bit hard to keep organized, and all that when you start having services exposed through load balancers. So what should we do instead? Well, we have another option, and it's becoming a preferred option, and that is to define ingress for your service. So we can still have our service defined, but then have an additional layer on top of the service called ingress. And what this does is it can reach out to AWS, and it can manage a different type of load balancer called ALB. And that application load balancer can be used for many services. So we can, with ALB, we can do path-based routing, and we can also do hostname-based routing. So we can actually send traffic to the appropriate service, and we can have it in front of multiple or even many services. So let's take a look at how we're going to do that. And this, by the way, is where the IAM role is going to come into play, because for this to work, what we're going to have is something that reaches out to the AWS API to build all of this, and that is going to have the appropriate IAM permissions. So we're going to walk through defining that. Okay. So the ingress resource is a new type of object. So you can see that we're building kind ingress with this. And we're going to give it some additional metadata. We're going to call this test ingress. And then we're going to tell it that the backend service name is test. So that's essentially going to be our selector for how to route traffic into our target. The ingress rules, by the way, is another interesting little thing. It's all handled using annotations, so we can actually rewrite the target to just be slash in this particular case. So there's some really cool things you can do with annotations using ALB Ingress.
Can I interrupt really quick?
Yes.
So there's just a lot of talk in the chat just about all sorts of different things. And I just want to mention that to check out the our containers roadmap. So the roadmap for the containers service team at AWS is publicly available. Brent, do you have a way to flash that up on the screen?
I need a way. GitHub.
I put a link. Yeah.
Oh, you did?
Yeah, I put a link in, well, in our chat, wherever that is. But anyways,
Oh, gotcha.
I'm also going to put it here. So if you have any, questions, or you're curious about if something's coming soon for a service, or if you don't see it and it's something you want for a container service, go to the containers roadmap, open an issue, talk about what your problem is, what you're looking for, and we'll build some steam, and hopefully you can see that actually get implemented. So
Yeah,
just wanted to
exactly.
shout that out.
And the banner's there on the bottom now, so you can see the address. It's super simple to talk through. It's AWS / it's on GitHub, AWS containers roadmap, then projects one. So it's the one and only project that I'm aware of on that particular GitHub account.
Anyways, resume. Thank you.
Yeah, no problem. All right. So what we're going to do here is we're going to build another service, and then we're going to route traffic into it using Ingress. And then we're going to do that using the ALB Ingress Controller. I can't tell if I click next or not. Okay, here we go.
And as you do this, one thing I really want to highlight is that the integration from the simple YAML definition in your service to configuration and what it configures in the load balancer for you is so nice. Like, this is really clean. I'm a big fan of the ALB Ingress Controller, just setting it up. It's really easy.
Yeah, me too. I love this thing. So this is my preferred way of handling ingress for a cluster. I think the ELB method is still a bit simpler. So if you're doing something just for a demo or something like that, then yeah, absolutely just expose a service type load balancer. But if you want longer term exposure, you're doing something especially at a production level, then going with ALB has all kinds of additional benefits, like auto scaling of your load balancer, and again, having only one that you have to manage that can route traffic to all of your services. Okay, so this is where the IAM talk is going to come in. What we're going to do here, we introduced a feature, I forget which version of EKS we rolled this out with. And this, by the way, is where a bit of this is EKS specific. So if you're doing this on a DIY cluster not in AWS, then this part of it is probably not going to be super useful to you. Exposing using an ingress controller that's generic, that's a Kubernetes object, but the ALB ingress controller specifically is dedicated to AWS. So what we're going to do here is we're going to associate an IAM OIDC provider. Adam, what's an OIDC provider?
So this is a way for essentially our cluster. I'm going to do it very high level, but this is a way for our cluster to talk through OIDC to IAM. And this is short way of putting it.
Yeah, you got it exactly right. So what we are going to do is we're going to connect our cluster to IAM. And then once we've done that, we're going to deploy the relevant RBAC roles that are necessary for the ALB Ingress controller. And by the way, if we look, I'm deploying this straight from the official Kubernetes GitHub location, Kubernetes SIGs, AWS ALB Ingress Controller. So this isn't something that's likely to change. The one variable here is the ALB Ingress version. I have that set right now. So you can set that yourself. You can adjust the path yourself, whatever is most appropriate for you. But once I've done this, then it's building a cluster role binding, and then a service account for the ALB Ingress controller. Um, we then are going to create an IAM policy, and this is, again, AWS specific. We're even starting with an AWS CLI command. We're going to create this policy that is going to basically allow for managing ALBs. So policy name, ALB Ingress Controller, IAM policy, and then the ARN for it. Once we have we're going to then save that ARN in our environment. And this is just another way to query for this piece of information right here, the ARN. So we're just querying using the AWS CLI. Output is tech. In fact, here, let me just copy and paste this command.
So Scion West asked, does Amazon provide you guys with those matching headphones? No.
No, I wish. No. So before this, I used to travel, let's just say extensively, and I'm not, but these were great travel headphones. This isn't a review of them or anything like that, but I had to repurpose them for something. So to avoid echoes and stuff on the stream, this is a good way to use the headphones. I even had to replace the ear cups recently. I've worn these so much.
Me too. And by the way, so I got these because of your recommendation, Brent. And I've had these for a
Nice.
couple of years, and they're like the best. Not trying to plug any headphone brand, but man, they're amazing. Good
Nice.
question.
All right. Where were we? Okay, so we have the policy ARN stored in our environment. Hang on. So what we're going to do next is this is an EKS control command that we're going to create an IAM service account. So this is shortened to URSA in a lot of references. And what this does is it allows us to use an IAM role in our pods. So let's talk. We're going to run the command because it takes a minute, but then we're going to talk through the options. Cluster is my cluster name. Namespace, cube system. Name is going to be ALB Ingress Controller. And then we're going to attach the policy ARN that we just stored in our environment a second ago. And we're going to override existing service accounts. And then -- approve is just sort of the final I think that it does it in dry run mode unless you have approve as part of the command line. So yeah, that's what's happening. This is actually well, it's done. That's cool. It only took about a minute or so, and what it did is it added some bits to the control plane that allows for us to be able to use this policy in our service or in our pods. All right, next step, we're going to deploy the ALB Ingress Controller. And this is back to being, relatively generic. So what we're going to do here is we're going to download the manifest for the ALB Ingress Controller. We're going to substitute the cluster name in the manifest. I guess it's set to dev cluster. And then we're going to replace that with EKS Workshop EKS Control because that's my cluster name. And then we're going to kubectl apply it. You could certainly have just downloaded this file and then, edit it yourself.
And Brent, a question came in Can that IAM role binding be done at the granularity of the namespace?
That's a good question, and I think you can get, I don't think those things are really matched up because you do it at the granularity of the pod. So I think that's even better than doing it at the granularity of the namespace, if that makes sense. We do have a link here for the documentation to URSA, IAM roles for service accounts. And let me just pop that onto the screen here. And you can see that this takes you straight to the latest user guide for URSA. So definitely explore that, but I believe the answer ultimately is no because you're binding it to a pod. All right. So let's check to see if our deployment was successful. I see logs. That's a good sign. There's our startup. You can see the version that we started up, and I think everything is looking good so far. Okay, so then we need something to deploy. So what we should do is knock out deploying this 2048 game. And again, this is a great just example deployment, and it comes straight from the SIG. So it's kept up to date and all that stuff. We deployed our game resources, which is the namespace, and then the deployment for the pods, and then the service. So the next thing we would deploy would be the Ingress object. So that deploys the Ingress controller, and that will set up our ALB. And when we do that, let's do a get ingress, and you can see that we now have an address. Just like before with our load balancer, we had an address. This is a DNS address, but it's not going to work right away because it takes a few minutes for ALB to come up and go healthy. It's only been 14 seconds. So we're going to wait a minute. We have a note here. It could take 2 or 3 minutes for ALB to be ready.
Which, by the way, is going to cut right to the end of the show here. So,
oh, we have a couple minutes. I wonder if anyone's going after us.
Well, I don't have any private messages yet, so I think we're okay.
Sweet. Do we have any other questions?
Let's see. No, something around this all supported in CloudFormation. I just don't know the context of what that was.
Yeah, so let's just talk through the CloudFormation stuff versus Kubernetes stuff. What we have is essentially a sort of a split between what should I put in CloudFormation and what won't I put in CloudFormation. CloudFormation is used to build AWS objects, but Kubernetes and all of these manifests and YAMLs that we just installed are used to build Kubernetes objects. Sometimes there's an overlap. Like, for example, I just built an ALB, but I used a Kubernetes manifest to do it. So there's not going to be any CloudFormation to make that happen. But it's still infrastructure as code. So by the way, our ALB just went healthy, and you can see that we're now routing traffic into our service. So we can totally, if I knew how to work arrow keys, we could totally sit here and play 2048.
Don't do it. This game is so addicting.
You know I've beat this game, right?
I didn't know that, but that's pretty awesome.
Yeah, so I never play seriously since doing this, but here's my screenshot from back when I, again, used to sit on airplanes for hours and hours of my life. I got all the way up to this. I consider this beating it because I had, like the perfect doubling from one square to the next. Can't do any more than that as far as I'm concerned. So this was my stopping point. After this, I retired from Pro 2048, and
I
that's
was
it
just
for
gonna
me.
say, you could have had your own Twitch stream, just you playing 2048. You'd get at least maybe 10 viewers on a stream. But I want you to know the chat is very impressed with this, Brent, as am I, by
Oh,
the way, as am I.
sweet. That's amazing. So real quick, let's just look. We have a second load balancer in our console. It's, noticed the name is 2048 game, so this is definitely the one dedicated to routing traffic. So yeah, that's that. Are there any other photos? Or sorry, any other questions? I just saw the photo comment that
Yeah.
made me say that.
No, I think that this, because we got to wrap up, but the context of the cloud formation was around IAM bindings. So I think when you talk about creating IAM roles, that's the cloud formation or AWS CLI piece where we did that. But then when you actually create the role bindings, that's done through Kubernetes.
Yeah, exactly. And then that controller came up, the ALB controller came up, and it had the right role attached to it to be able to have permission to go and build an ALB and configure the ALB. And so it, has the appropriate permission to do all of that, but it can't really do anything else in my account.
Yes, and we have to wrap up. There's one other question about how granular IAM role permissions can be. That could literally be hours and hours of content
Oh
on
my
its own.
gosh.
But
IAM is super granular.
like you could do like tag based permissions, like they call it tag based access control like there's so many things you can do with IAM. It's pretty insane. But yes, you can get very granular. We got to wrap up, Brent. That was a great show. Thank you everybody for joining. Will we be back tomorrow? Yes, we'll be back tomorrow.
Yes, we'll be back tomorrow, and we'll tweet what we'll be talking about tomorrow morning. See
Cool.
you guys then.
Thanks so much. See y'all.